How does regeneration boost Rankine cycle energy savings? Imagine a power plant that uses steam to generate electricity. Now picture making that process smarter and more efficient without building new equipment. That's what regeneration does for the Rankine cycle. In a basic Rankine cycle, water is pumped into a boiler at low pressure and temperature. The boiler heats the water into high-pressure steam that spins a turbine, producing electricity. Afterward, the steam cools down and condenses back into water to repeat the cycle. Simple enough, but it can be made more efficient. Regeneration involves taking some steam from inside the turbine at intermediate stages. This steam is then used to heat the incoming feedwater before it reaches the boiler. Think of it like pre-warming your hands before going outside in winter. This process happens in devices called feedwater heaters. These heaters transfer heat from the extracted steam to the cold feedwater, raising its temperature. When the feedwater enters the boiler at a higher temperature, the boiler doesn't need to work as hard. It requires less fuel or heat energy to turn water into steam. This means the power plant uses less fuel overall, saving energy and reducing costs. Plus, preheating the water reduces thermal stress on the boiler, making it last longer and work more reliably. There are two main types of feedwater heaters. Open heaters mix the extracted steam directly with the feedwater, while closed heaters transfer heat indirectly through a heat exchanger. Both methods improve efficiency, but closed heaters are more common in large power plants. Extracting steam from different points in the turbine allows the cycle to use the thermal energy more effectively. The steam that is taken out still has enough energy to do some work in heating the feedwater, so it's not wasted. After transferring heat, this steam usually condenses and is returned to the cycle. The key benefit of regeneration is that it increases the average temperature at which heat is added to the cycle. According to thermodynamics, higher average heat addition improves the cycle's thermal efficiency. This means more of the heat energy from fuel is converted into useful work, rather than lost as waste heat. Because the boiler needs less heat input, fuel consumption drops. This directly cuts down on fuel costs and reduces emissions, making power generation more environmentally friendly. In large power plants, even a few percentage points of efficiency gain can save millions of dollars annually. Regeneration is widely used in thermal power plants fueled by coal, natural gas, nuclear energy, or renewable heat sources. It's a simple yet powerful way to get more energy out of the same amount of fuel. By recycling some of the steam's thermal energy to preheat the feedwater, plants operate more efficiently and cost-effectively. In short, regeneration boosts energy savings in the Rankine cycle by reusing steam energy to preheat the water before it enters the boiler. This reduces the heat needed to produce steam, increases cycle efficiency, and cuts fuel use. It's a smart way to make power generation cleaner, cheaper, and more reliable.